Good morning. I am Dr. K.H. Shaktimurugan, Associate Professor from Department of ECE at Narayana Engineering College, Gudur. I am going to do a small technical presentation on QNX architecture. QNX stands for Quantum Network Executive, which is a real-time operating system owned by BlackBerry. So this is the outline of the presentation. We have the introduction followed by the microkernel architecture, process manager, and the summary. What is QNX? QNX is a microkernel based real-time operating system designed to deliver extremely reliable and predictable behavior. It is widely used in safety critical and mission critical embedded applications where system downtime, unexpected delays, or crashes cannot be tolerated. It is built to support deterministic response time, ensuring that tasks execute within guaranteed deadlines even under heavy workloads. So it is designed for various applications like automotive applications, medical devices, industrial automation, aerospace, and defense avionics systems. And this particular RTOS is fully POSIX compliant, which is a major advantage. These are few characteristics of QNX. First one, as I have told before, it is a true microkernel architecture and it is using robust message passing based IPC, which IPC stands for interprocess communication. It is highly reliable and fault isolation is another important feature. It supports user space, device drivers, and it is real-time deterministic. It has full memory protection and isolation and offers cross-platform portability just because it is going to adhere to POSIX. So this is the monolithic architecture. There are two kinds of architectures. One is monolithic and the other one is microkernel. Monolithic architecture, as the diagram is showing, you are seeing that there is only one memory space, and in that memory space itself, everything is available. The user interface, scheduler, memory allocator, network stack, disk drivers, serial drivers, and applications, everything. So this is one disadvantage. There is one disadvantage in this monolithic architecture, that even if any one of these fails, then the entire system is going to be a failure. Now the next diagram that you are seeing is nothing but the microkernel architecture that QNX is following. In this microkernel architecture, if you see, this is the kernel space and this is the user space. The kernel space is having microkernel and the process manager. Both of them put together is what is called as proc NTO. Okay, and this is nothing but the user space in which you are seeing that the shell is present, different device drivers is present, user application is present, user interface is present, everything is available here. And the communication between any of these two takes place with means of something called as IPC. And if you look into this microkernel architecture, it is designed to be minimal, efficient, and deterministic. Only the most essential real-time functions will reside inside the kernel space. For example, thread scheduling and dispatching, interprocess communication handling, and then fast and predictable interrupt handling, memory protection and low-level address translation, then handling of timer, clocks, and high-resolution counters. So this is the main work that is being done by the kernel. So remaining whatever it is, it will be in the user space. And for example, network stack, file system drivers, UI services, all this will run in the user space. This will improve the reliability of the OS. And the design strictly separates policy in user space from mechanism in the kernel space. Thereby, it is going to ensure flexibility. What will run in the user space is all high-level OS services execute as normal protected processes. That is, what and all it includes is file systems, device drivers, complete network stack, graphics rendering services, middleware components, user applications, and daemons, including the resource manager responsible for representing devices as logical files. This user space design means any component can fail without crashing the entire OS. So if any one of these applications, as in the previous diagram, if you see any one of these application fails, means only that application will be failing. The remaining system will be as it is. So this is the process manager. If you see, this is a microkernel and this is the process manager. As I have already told you, this put together is what is called as the proc NTO. What is the role of the process manager? It acts as the core user space executive responsible for managing all processes. So whatever is going to happen outside in the user space, all of it will be controlled by this process manager. So it is going to handle process creation, execution and deletion, and ELF program loading and linking, memory space creation and management for each process, path name resolution and mount point management, permissions, environment variables, and file descriptor tables, which we'll be seeing in the following lectures. So works closely with the microkernel to implement POSIX process semantics, and it is essential OS services such as queues, timers, signals, and resource managers depend on the proc NTO. So this is the summary of this presentation. QNX RTOS is engineered for real-time, safety-critical and mission-critical applications, and its microkernel architecture ensures reliability, modularity, robustness, and predictability. The combination of message passing, resource managers, user space drivers, and high-precision scheduling sets QNX apart as a leading RTOS in modern embedded systems. And this is the last point, which is very important. By isolating system components and implementing a standard POSIX interface, QNX provides both the stability of an RTOS and the flexibility of modern operating system. Thank you.